Boston, the Deputy Director of the FIATech Consortium. And on behalf of all of us at FIATech, I'd like to thank you for joining us today for what marks our 80th live webinar broadcast spanning the past 5 years. Today we have an exciting hour set aside to discuss Gary Technologies' success at deploying BIM for risk management on mega projects, and for which they were recognized in March from FIATech with the SETI Award in Scenario-Based Project Planning for this achievement. Now I'd like to welcome and introduce our speakers. Mr. Tariq Begat has 29 years experience in project management and project controls. He has solid experience in project control functions, including estimating, scheduling, cost control, value engineering, and risk management and document control. Mr. Begat has served the engineering and construction industry, both in the design office and in the construction field. His experience spans power, infrastructure, biopharma, and commercial. He's the Vice President for Gary Technologies and is the Managing Director of the Middle East operations. He is an industry leader in the implementation of building information modeling and using BIM in facilitating value engineering, planning, and risk management. He pioneered the facilitation of risk-based value planning workshops utilizing BIM technologies for the coordination of the construction at the World Trade Center site for the Lower Manhattan Construction Command Center. Before joining Gary Technologies, Mr. Begat was a senior principal at PMA Consultants and led its New York office. Prior to that, he worked with Louis Berger, Washington Group, and Saldo and ABB. Joining him today is Dennis Sheldon, who is the Chief Technology Officer at Gary Technologies. Thank you both for joining us and to share sharing with us your case study. Let me turn it over to you now.
Okay, so I'm assuming I'm on the air?
Yes.
Okay, thank you. This is Dennis Sheldon. I'm one of the founders and CTO of Gary Technologies. I'm just going to offer a couple minutes on Gary Technologies and what we do, and then the real body of the presentation is going to be Tariq, who's been driving the implementation at the World Trade Center site. So Gary Technologies may be familiar to some of you, but let's see, we are, I don't know if I've gotten keyboard and mouse, so Tariq, if you can just go next. Gary Technologies is essentially a building information modeling technology and consulting company. We are expanded into kind of broad virtual design and construction and integrated project delivery services. Next, kind of the three functions that we provide in the industry are sort of integrated project delivery consulting, always oriented toward the technical side of the process. We develop some building information modeling technology and communications software, and then next we are involved in both academic and industry initiatives, serve on some of the panels regarding interoperability, and try to foster the community of collaboration around ABC and BIM. Next. Our processes tend to be a hybrid of consulting and services, and we're always sort of looking to define the systems underlying complex project delivery problems, and we approach that through, again, hybrids of our software, other commercial software, and consultancy, both technology transfer and also integrating in the project team. And I think the World Trade Center work is going to be a good example of that kind of approach. Next. Just briefly, we serve our projects through a broad international presence. So, of course, due to the international flavor of many projects, where design may be conducted in New York or Paris or London, but actually executed in Asia or Abu Dhabi or the Middle East, that's really sort of one of the strengths of our approach, is to be able to cover the world and the kind of cross-disciplinary and distributed project teams. Just some of the sectors that we're involved in. We're relatively well known for work on sort of the complex building types, both including our heritage, the Frank Gehry work, but also many other projects, including what's shown the Beijing Olympic Stadium. We do other kind of large commercial projects, as shown on the right, large infrastructure, often mixed use, where there are complex either of scale or performance or geometry. We've been getting involved also with some of the more critical systems types of projects, hospitals, data centers, and the like. And then kind of at the larger scale, again, what we'll show you regarding the World Trade Center work is really trying to take BIM to the urban and global level, and some of the overarching governance and management issues around it. Next. And you can just step to the end of this, Derek. So these are just some of the places that we focus, really looking at some of the complex and kind of higher value problems behind BIM, anywhere from the financial planning upstream and optimizing projects for cost and value, through some of the more traditional things, design rationalization, design to fabrication, performance-driven optimization, which would be looking at either energy or other functional criteria and running optimization of the building typology or the building organization against those types of values. And then downstream, project controls, construction logistics, sort of virtual design and construction work. And then always looking at the overarching governance and information management side of things, really sort of managing the data through the integrated project delivery ecosystem. Next. That's all I have. I'd like to turn it over to Tarek, who is going to focus in on one of the projects we've been involved in that we're very excited about. I want to also, just in passing, thank FIATEC for the opportunity to speak today and for recognizing this work as you did in March, and also clearly our sponsors at the LMCCC and the very broad set of collaborators in New York City that we're working with to undertake this work. And with that, I'd like to hand things over to Tarek, who's going to take us into the case study itself.
Good morning, everybody. As Dennis mentioned, and I'd like to emphasize our thanks to the Lower Manhattan Construction Command Center and the vision they had, both in terms of risk management and in their implementations, in coordinating the task at hand. Our client at the Command Center is the Lower Manhattan Construction Command Center, which was chartered by the executive orders from the governor of New York and the mayor of New York City. Its mission is to coordinate and communicate and mitigate impacts of construction on the community and amongst the construction community as well. Since 9/11, the flow of public investment in redeveloping Lower Manhattan, a lot of private funding as well funneled into Lower Manhattan. From 2002 to date, there's about 150 new construction projects. Some of them have been slowed down due to the economic crisis last couple of years. But what you see here in red is basically current construction projects in Lower Manhattan, and that's all around the World Trade Center site. If you can see my pointer, this is the location of the World Trade Center site, which is shown by the Freedom Tower, Tower 3, 2, and 4, and in between here, within the 16 acres, is also the Memorial and Transportation Hub that the Port Authority manages. The Command Center basically deals with 3 spheres of influence. What you see in red is the regulatory agencies and that are involved in Lower Manhattan: State DOT, EPA, OSHA, DASNY, DEP, the FCA as a funding agency. What you see in blue is the construction community in Lower Manhattan. That includes the DDC, the Port Authority of New York and New Jersey, the Lower Manhattan Development Corp, corporation. You have also utilities. The MTA has major projects, the state DOT, and the private. A very quick review about risk management and its importance in this case. We're talking about the development at the World Trade Center site, which comprises about 16 acres and about $16 billion of program space. A quick review of all the mega projects. You can see there's a major cost overrun and schedule delays on these mega projects, and there are systematic and systemic characteristics in mega projects that are conducive to risks. Usually there's more than one stakeholder and there are multiple funding sources, which we see at the Trade Center site. There is multiple programs and projects that coincide in space and in time. Within these programs and projects, there's multiple sub-projects, and the design is being packaged and developed at different stages and different timings. There are many contractors, construction logistics, and the site, on-site, and the interfaces between the contractors becomes very crucial. Then you have the community at large, regional, national, and that put a lot of additional constraints on the site. World Trade Center site is probably also attracts international interest, and the community involvement in the development and the understanding of what's going on site impacts the environmental process, the environmental statement, and the development of the project design. There are also political interests and politically mandated milestones that impact the project and the structure and the sequencing of projects. So all these constraints lead to a lot of risks on these mega projects. Primary risk in all this is governance and the interagency coordinations. In Lower Manhattan on the World Trade Center site, there's about 5 different stakeholders, different agencies with different requirements, and then on top of that you have the funding agencies, and you have oversight and interest from the state, from the Memorial Foundation, and a lot of interested parties. Funding and oversight requirements that needs to be met. You have also the political and mandatory milestones. These present major risks on projects. These projects have tremendous environmental impacts on the locally around the site. Imagine Lower Manhattan with only 2 tunnels access and 1 bridge, and all construction material and equipment is passing through a very narrow grid of roads. The development of the community itself and the revival of the community and meeting the constraints and the aspirations of the community is very important. And then, like any other project, scope, cost, and schedule are main risks on the and are the manifestations of the risks on these mega projects. Coordination of design and integration between different agencies is also very important. Logistics laydowns, and then the demands on resources, labor, and material. These are very typical in most of these projects. A key problem is on mega projects is you usually have construction starting while engineering is still in its early evolution. There's fast tracking, packaging, early works, construction on piling or foundations, excavations. Slurry wall begins before completion of design. Then you have all the existing utilities and relocations and all that. A quick review of the life cycle in a risk on a project. At the beginning of any project, risks are very high, but the amounts invested and the amounts at stake are very low. Excuse me, sorry. So what you see in orange here is the curve of the risks as the project data develops and more information through the design is being compiled. The risks begin to taper down, but we are digging ourselves into the project, so the amounts at stake are becoming higher and higher. A very critical point, if these two curves intersect during the execution of a project, it means that the any risks identified at that point in time are going to cost a lot of money to mitigate. So basically, the idea of the risk management program is to try to mitigate as early as possible project risks in the early phases of a program. On a program like the World Trade Center site with multiple agencies with varying timelines for the different projects, it's very critical. Early on, the Lower Manhattan Command Center adopted a risk management approach to the projects, identifying the project coordination risks, and basically it's a 6-step process with reviewing projects, identifying potential risks, modeling these risks for analysis, and then creating risk ranges, and we'll talk a little bit about that. Then we simulate and run the analysis and calculations and summarize the outcomes and results and basically manage the risk process. There are two aspects of the risk assessment plan. One is the qualitative aspect, identifying the risks, ranking them, and developing mitigation plans. The other is a quantitative assessment, which includes a creation of a schedule and cost model, ranging these costs and schedules, and then while soliciting the team's input, creating simulations and statistical analysis for these results, and then report the process. Typically, we start with a raw risk data. Basically, the team provides input on their potential risks. Now we're talking about multiple agencies. Initially at the command center, our expert team of consultants working at the command center, and Gary Technology was one of them, prepared what the command center saw as major risks between the projects due to coordination and due to interfaces between the projects. A typical risk register would have a risk statement or a risk item with its probability and its impact on cost and schedule. These are basically subjective assessments with ranges. Basically, probability is defined as very high, high, medium, low, very low, and the impact is also identified as very, very low to very high. And a score is, and again, this is a very subjective scoring system, is identified based on the probability and the impact. In the quantitative assessment, it takes a more thorough approach where we look into the, if we're looking at the schedule, we're looking at the ranges on dates, we're looking at critical path versus criticality of activities, and we basically identified 3 scenarios, either pessimistic, which is a worst case scenario, an optimistic best case scenario, and what is most likely, and that's usually the deterministic schedule that is presented by the agencies. One of the challenges we initially had was basically the deterministic schedules were always clarified or qualified as either aggressive. Some of them were blue sky schedules, were drafts, working drafts. Basically, another word of saying this is very optimistic or very aggressive. So we had to deal with understanding what really went into activity durations. We basically, the command center started analyzing the schedules and looking at the activities, providing these ranges, which is basically range from pessimistic to optimistic and the most likely. And a multi-color simulation basically calculates the basically initially randomizes schedule calculations, and we can run the calculation maybe 1,000 times, 10,000 times. and based on that we get a range of probabilistic dates. Some of the dates have 100% probability, which are towards the tail end of the curve. Activities that have very little chance of happening are at the front of the curve, and in between is what would be the deterministic schedules or the standard schedules the projects are working with. We have defined 80% probability on this project as the criteria for defining the amount of risk that is acceptable. So when we use the term P80 or probability 80%, this means that for a given activity or for a given project, it has a likelihood of occurring on or before that date 80% of the times. We also look at criticality and instead of critical paths. Schedule and risk are associated, and the scalar is a proven scalar that if project duration extends or there is a risk of project delays, project costs also follow. So let me take you back in time to basically around 2006, and discussions were going on in 2006 forward, looking at what the site would look like on a memorial event in 2009, and what would the site look like, and how we, what kind of celebration, what kind of access to the site, what kind of construction status would the site be. And that was a question posed by the governor and the mayor to the executive director of the command center. And basically there were different responses from different agencies. There are about 13 major projects. There are 5 main stakeholders on the project. And we started looking at the schedules historically and how they how the schedule updates reflected the progress, and we analyzed a very simple metric of remaining activities on the schedules. We had about 25,000 activities on the integrated master schedule for the program that is provided to us through the different agencies. And we created a summary of necessary activities, hammock activities if you want to call them, that basically represent the project regardless of minor design changes or modifications. And those were around 1,600 to 1,800. They varied slightly from one day to the next. And what you see in different colors on these charts are the different schedule updates. This was the schedule update, and then every 6 months we've tracked historically what has been going on. And you can see that the end dates on the projects were pretty much pegged on or around the same end date, but there's very little progress happening on the early activities on the project for almost a couple of years. And that's where this covers the period from 06 basically to beginning of 08. What we initially started doing is creating a 4D model of the entire schedule as it is, as provided by the agencies, and analyzed the schedule. We used this model basically as a diagnostic tool. We've looked around at every corner on the site. We looked at the different interfaces between projects, and we tracked those areas in time and see what's the implication of construction and at the different stages. So this is a look at the southeast corner of the site. You can see the MTA box. You can see a Silverstein site, and you can see the interfaces between. And we track the same location in a different view and looking at how excavation work proceeds in different on the different sites. We're basically separated by a fictitious or line that runs around here, and you can see different projects running in different phases. And each of those images identified certain risk on the project. Some was interfaces between construction equipment and area allocations from one project to the other. Those are separate projects. We've also used the 4D model to compare actual versus planned at any given date, and looking at the site from different perspectives, and identifying again what's holding progress behind. We've looked at temporary construction and phasing, and the impacts of the different projects on each other. Mind you, the World Trade Center development is occurring with two active subway systems, with the path running from New Jersey, carrying about 67,000 passengers every day, and the one-line subway, which you see here in red, carries about 22,000 passengers a day. There's no station on site, but it runs across the site from Chambers before the site to Rector. Looking at different temporary conditions, temporary construction, we started analyzing these images and came up with kind of a risk register for the command center. And the idea was to actually have a intensive 2-week workshop, bringing in experts from around the world to look at the project, analyze the risks, come up with a risk register, come up with a risk assessment, and also evaluate the schedules, and come with potential mitigation plans. All of this within a decision framework that basically looks at the preliminary interfaces between the different projects, run a schedule and cost risk analysis, develop mitigations and workarounds and trade-offs, and calculate regional costs, benefits, and intangible impacts. In the first week of the workshop, develop the model interdependencies and develop schedule likelihoods. And the second week of the workshop, develop a mitigation and model those mitigations, and basically come up with different scenarios and likelihoods, and then use that as a risk management process that continuously looks at the site and is updated periodically, which we continue to do until today. This initial workshop was conducted, as I said earlier, in February of 2007. And basically, we looked at the project schedules. The expert team provided, utilizing the BIM model, the 4D was available for the team, and it facilitated the understanding of the risks. So at any point, we'd look around at any given date where people are looking at a certain interface in the future, analyzers rotate the model, play with it, and provide input. A result of this risk workshop was the dotted line, where the pre-mitigated logic and risk-adjusted schedule. That has since been mitigated, so this is only a reference chart. And we came up with different, utilizing the Monte Carlo simulation. We randomized the schedule for about 1,000 iterations and got the risk distributions basically for every component of the project. What we were able to do during the workshop is create and allow the expert team to look at basically two instances of schedules. One is the baseline schedule, if you may, which you see on the left, and the other one is a P80 schedule, which is basically a probabilistic schedule with 80% chances of materializing. And that schedule has identified and corrected logics that are based on the risks that we have seen. But it's pre-mitigation, right? So it's a pre-mitigated schedule, and you can see this simulation running from early 2008 all the way through the completion of the project. What is very interesting here is you can look at a frozen moment in time in December 2009, which is a few months back, and comparison between the baseline schedule back in 2006 with the P80 that was developed in the workshop in 2007, early 2007. This projection or forecasting of the project status is almost 2 years old, and I'm sorry. These were pictures of the site taken in December 2009, depicting where the site progress is, and it is very much consistent with the risk management workshop. Since then, we've continued with the risk workshops. We've updated. We've continued to manage to that initial workshop through 2007. In 2008, we updated the risk assessment in March and again in June. And based on that, the Port Authority has adopted in October, based on also the risk assessment that they've conducted, which came up with very close results. They've created the new roadmap for the project development and project schedules, which are basically currently now are being tracked. So putting things back into perspective, the command center is utilizing BIM and 4D in coordinating construction projects in Lower Manhattan, and you can see at a very high level. But also we're utilizing this information on the web. A lot of this information is readily accessible on lowermanhattan.info, where we are now updating what used to be a GIS map of the project. We're updating it with Google Maps, where we are going to have 3D and 4D projections of where major projects are. Provided information is suitable for public consumption. A lot of the development in the World Trade Center site is confidential and privileged, so some of the progress may not appear on the World Trade Center site, but all the other projects in the vicinity are being tracked, and they're being tracked now they have been tracked for the last few years in time. What you see here are the different projects, street projects, street changes. Each project has a different coding and a large database behind it. We're also, you would be able to get some brief data about the project, description of when it started, when it's ended, even the permitting status of the project, who is building it, who is the contractor on site, and so forth. Now that's being taken into the 4D world, and it should be launched very soon. So from a very global city view of what's going on to detailed construction logistics and temporary construction and crane movement, we have utilized the BIM, or the Virtual Designer Construction tools, to basically manage project risks and help mitigate interagencies and coordination problems. And pretty much concludes my presentation, and I'd like to open it for questions and answers.
Great, thank you, Tariq. I have a couple of questions, and if anyone has some that they'd like to send in, please do so using the questions tab on the control panel. First question is, what software was used to study probability, and what software application was used for the project schedule analysis?
So
I guess that would be...
Okay. Hello?
Yes?
Yeah.
Okay. So the software used for schedule analysis is P6, which is a Primavera Arco software. For the risk analysis, we used PertMaster. Just at around the time Primavera was purchasing and procured and acquired PertMaster. PertMaster basically runs Monte Carlo simulation type of analysis or Hyperbian simulations. So we use these two programs basically.
And then the 3D and BIM side is done with a combination of Digital Project, which is a software application we've developed, and some of the latter stuff that you saw in integration with Google Earth. Tarek, just before we take the next question, could you just go to the end slide, just so people have a way of contacting us?
The end slide?
Yeah.
Would it make sense to use these technologies for small or mid-sized projects instead of mega projects? And what would be the applicability there?
Well, yeah, it's fine, Tarek. So that's a question that sort of always comes up, and I guess the question then is, what do you consider small? These sort of techniques have been used with, I guess, I'd say mid-sized, mixed-use commercial construction, and of course, even residential construction is appropriate for if you consider maybe work at the development level. I think it might, at this point in time, be overkill for single-family residences, but I think that the technology continues to evolve. Things are getting easier and easier. The cost is going down, and I would expect that you'd see these sort of techniques applicable to increasingly smaller and lower cost projects. Tarek, do you want to add anything to that?
Yes. So in terms of the techniques, the risk management, you basically, if you've done a project 10,000 times before and you kind of have your hands around totally all the risks on a project, these tools may be superfluous. But if you have, even if it's a small but a complex project with potential risks that require early on visibility, and with visibility I mean visibility to the stakeholders and the decision makers of the risk and a clear understanding of what these risks are, as well as the visibility to the project team and the executioners or the people who are responsible for delivering the project. Understanding clearly these risks, then these tools, the visualization and the risk management tools, are very important, even on the smallest of projects, as long as they have the complexity that requires the risk process. In general, now I see more and more trends, even on the simplest of projects, that at least the visualization and the design coordination utilizing BIM is being conducted.
Thank you. Next question. This person commented, excellent demonstration of technical and project management, including schedule, cost, and risk, information integration that is realizing the FIATech vision. Question, how did you create a standard language, including WBS, and then a common 3D model data interchange rules?
So on the So one of the early things the command center has developed, and that was maybe before 2000, that was early in 2006, early 2006, is worked with the stakeholders in developing a standard WBS at the enterprise level. So basically, a enterprise hierarchy that leaves the WBS within each project to the different stakeholders, but the identification of individual projects within a program follows through the EPS, or the hierarchy of the WBS. As far as the 3D BIM model, it was more of a challenge. A lot of the design data, the entire model was developed by the Lower Manhattan Construction Command Center by data received from the different stakeholders. Some agencies had some 3D models of some of the project components. We've utilized those and integrated them either through IFCs or imported them directly into digital projects. Some projects did not have 3D documentation, 3D drawings, so we've actually used the 2D drawings. Some projects were early design phases that we used PDFs that we've integrated. If you look at the bottom screen here in the model, on the bottom right, you can see the floors of this program space, and these are images actually from PDF. They were not completely modeled. While on this side of the transportation hub, the temporary structures were even detailed from the design drawings, right? So there are different levels of model development that we had to accommodate.
Yeah, if I can just add to that, I think the question is really a pertinent one. The notion of how you can develop comprehensive integrated approaches dealing with widely disparate data. That's really, that's really central to the agenda of this project, because we are dealing with so many different stakeholders and so many different types and qualities and levels of detail of data, and it really is, I think, part of the mandate of the project, but also really, I think, our aspiration as an organization to support the potential for federated data sets and to be able to create this kind of synergy from data without requiring some sort of unified approach that everybody has to adhere to.
Great, thanks. Next question, how involved were the construction subcontractors in the risk management workshop at the beginning of the project? Or I guess maybe even more generically, what is the role and opportunities for the subcontractors when starting something like this?
This is a great question. So the unfortunate thing is, in this process, even the contractors were not involved because it was at an interagency level. The command center is a facilitation organization, does not have jurisdiction over construction, so we invited the agencies in to, and they would bring whoever they would see appropriate. So some agencies brought in their contractors, some agencies did not. In general, it is, I think, on the risk management process, the input from from everybody on the construction team, the design team, subcontractors, is of the utmost importance. In this case, we're looking at interagencies interfaces and risks of delays due to these interfaces between the agencies. We did not look at specific contractors, means, and methods unless they impacted another agency's scope of work. I hope
Thank
I
you.
answered that question.
Thanks. Next question. Reference was made to a decision-making framework on slide 51. You mentioned the quantitative and qualitative categories for decisions. What type of and how is strategy involved in the decision-making process, and does it include a choosing by advantages system, for example?
So one of the outcomes of the initial workshop and setting up for the decision process is what we call scenario-based optioneering, in which we've utilized we utilize the visualization and the BIM model to model different scenarios. If decisions were made if decisions A, B, and C were made, this is what the schedule impacts are, and this is how it would flow. These options then were evaluated in terms of schedule impacts and in terms of cost impacts, and then on a secondary level, we actually we had different consultants and different experts from financial and economic consultants as well, who developed a model for evaluation of regional cost-benefit analysis for each of the options. So basically for each mitigation option that was developed based on the risk workshop, there was a direct cost and schedule impact of the mitigation, and there was a regional cost-benefit analysis for each of the mitigation scenarios.
Thank you. Next question. Do you make virtual visits with stakeholders where you can navigate through the model in a specific point of a project?
Continuously. The command center has what is called the CCR, the Construction Coordination Room, and it's basically every week it's meeting with the stakeholders individually, or sometimes if there's an issue between two stakeholders, is utilizing the model, and our basically the model is always in the updated and maintained in the CCR, and the agencies come in and we facilitate utilizing the model and the schedule, facilitate the coordination issues every week.
Great. And last question. Do you support, or does Gary Technology support standards activities to achieve the enterprise-wide integration that you need? And if so, which ones?
That is certainly
the question.
I'm assuming probably there's IFC's industry foundation classes with Building Smart Alliance. Within FIATech, we are looking at the advancement and acceleration of the ISO 15926 for capital projects and process plant industries. Are there any standards that you're aware of that you're working with, I guess, to achieve the interoperability integration that you're getting?
Right. So again, Gary Technologies is really oriented towards an open standards way and a federated way of approaching data management. So we are strong proponents of IFC. We're members of Build Smart. We we participate in the leadership and guidance work that's done there. And the technologies that we use and develop are natively IFC. They're built on the IFC object model. We are, as you saw, maybe not so much in the open standards, but what you saw toward the end is really about developing broadly distributed and integrated databases for project information. So it's I can't say that we're all the way there, or that anybody in the industry is all the way there, but that's really really core to our mission, is to approach projects from an open standards way of integrating federated information.
Okay, and actually the last question that just came in kind of dovetails that point. They said, getting back to modeling platform, don't you think that there's going to have to be the development of some broadly accepted data format in order for these technologies and methods to gain widespread use?
Absolutely, and our orientation is toward IFC. Those that you have to give a fairly a well-informed audience. So there's certainly a lot of debate about whether IFC is good enough, new enough, but it is, in our view, a great sort of common denominator, and I'm sure it'll continue to evolve. But that is really, we're promoting and encouraging IFC as an interoperability approach for everything that we do. Nicole, if you wouldn't mind just flipping over, I guess right toward the end, but I just wanted to, if you could just give me the presentation. I just wanted to make sure that people have our email addresses.
Sure. Okay. Well, Dennis puts up his contact information. I just want to thank all of you for spending the past 60 minutes with us. Be reminded that a recording will be made available in the media library on the FIATech website within the next few days. Thanks again to Dennis and Tariq for sharing your story with us. And I hope you'll all be able to join us next week for a presentation by SIFI at Stanford University and DPR Construction, recipients of a SETI Award as well back in March. Their presentation will be on real-time supply chain management using virtual design and construction and lean principles. So with that, thanks everyone. Have a great day. And thanks again, Dennis and Tariq.
Thank you, FIATech, and thanks for your time, everybody. And certainly, if you would like to follow up with us, we welcome the conversation.
Great. Thanks. Bye.